It seems like everywhere you look in AI these days, there's this constant struggle to manage the overwhelming amount of information that's being thrown at these systems. Especially when we talk about large language models, these LLMs, they're learning, they're adapting, they're processing so much, and one of the most fundamental things they need to do is remember past interactions.
It really is quite a remarkable thing.
Right.
It's what allows them to generate responses that not only make sense, but also feel tailored to you. Like having a conversation that actually flows, as opposed to just a bunch of disjointed statements.
Yeah, I've definitely had my fair share of those disjointed conversations. But the whole memory aspect is really key, right? It's like how we as humans build our own understanding of the world.
Absolutely, you've hit the nail on the head. It's the foundation for everything else. Context, personalization, reasoning, it all hinges on that ability to recall and integrate past experiences. It's the bedrock of these LLM agents becoming, well, more intelligent.
Okay, but here's the catch, and it's a big one. As these LLM agents start to accumulate more and more memories, kind of like how our own minds can get cluttered, efficiently retrieving the right information at the right time becomes a real challenge.
Oh, absolutely.
It's not just a matter of storing a bunch of data, it's about being able to find the right needle in a massive haystack of information.
That's exactly right. And the issue isn't just the sheer volume of data either. The way that information is stored, if it's just raw, unprocessed data, it can be incredibly inefficient to search through. Think about trying to find a specific book in a library where all the books are just piled up randomly. It would be a nightmare.
Yeah, that's a great analogy. It's chaos. And then there's the whole question of integrating knowledge from different tasks, different conversations. Like you might learn something in one context that's incredibly valuable in another, but without a sophisticated way to connect those dots, it's just lost potential.
It's like having all the pieces of a puzzle, but no idea how they fit together.
Exactly. And that's where a team of researchers from AWS AI steps in. They've developed something called MemInsight. And from what I've gathered, it's a completely new approach to making the memory of these LLM agents, well, smarter and more efficient.
It's really quite ingenious.
So what they're doing is enhancing the way these agents represent and access semantic data. And for our listeners, the key takeaway here is that MemInsight is about moving beyond just storing data. It's about empowering the AIs to understand what's important to remember.
And that's a huge leap forward. It's what they're calling autonomous memory augmentation. Instead of just passively storing raw data, it's about actively enriching that data with semantic understanding, with contextual details.
Making the agent's memory not just bigger, but genuinely smarter.
Precisely. And that's what we're going to unpack today in our deep dive into MemInsight. How does this actually work? What are the key innovations that allow LLM agents to remember and use information in a more sophisticated way? We're not just interested in the results. We want to understand the mechanisms behind this breakthrough.
And I think that initial stage where the AI itself is starting to understand the data it's storing, that already hints at a major innovation.
Oh, absolutely. So that's one of the things that makes this approach so fascinating. So let's dive into those mechanisms, shall we? Let's explore how MemInsight works and why it represents such a significant advancement in memory management for LLM agents.
Yeah, let's get to the heart of it.
So when we talk about autonomous memory augmentation, what exactly does that entail? Well, think about how we as humans focus our attention. We don't try to remember every single detail of every experience, right?
I mean, I wish I could, but yeah, not happening.
It's just not feasible. Instead, we instinctively prioritize. We pick out what seems important, what's relevant to our current situation. And that's exactly what MemInsight aims to replicate.
Interesting. So it's selective remembering based on relevance.
Exactly. And it achieves this by autonomously generating what are called augmentations. These aren't just random bits of data. They're actually encodings of semantic and contextual information that's been extracted from the agent's memory.
Okay, so like adding labels or tags to the memories to make them easier to find later.
Precisely. You can think of them as highly descriptive tags, if you will, that make it much easier to identify the most relevant pieces of information when they're needed.
Got it. So the AI is essentially pre-processing its memories to make them more searchable.
And the ultimate goal, of course, is to dramatically improve memory retrieval. By associating these relevant attributes with each piece of information, the agent can sift through its past interactions and its knowledge base far more effectively.
Okay, that makes sense. But how does MemInsight actually pull this off? What are the nuts and bolts that make it work?
Well, the entire framework is built around three key modules: attribute mining, annotation, and memory retrieval. And they all work together in a really elegant way.
Okay, break it down for us.
So let's start with attribute mining. This is where it gets really interesting. MemInsight utilizes a backbone LLM. And you can think of this as a powerful AI model that's specifically trained to understand the meaning behind the data. And its job is to identify and define the most important semantic attributes from all those user interactions.
Okay, so it's like the AI is learning to categorize its memories.
Precisely. And the research outlines two main ways it does this: entity-centric and conversation-centric.
Okay, what's the difference?
So entity-centric mining is focused on specific items or entities that the agent has come across. Think of things like movies, books, products, any sort of distinct object. And what it's doing is identifying the core characteristics of these entities.
Like for a movie, it might be the director, the genre, the year it came out.
Exactly. Or for a book, it might be the author, the publisher, the main themes. It's all about extracting the key properties that define that specific entity.
Right, so it's about understanding the what of the memory. And conversation centric, is that more about the how?
That's a great way to put it. Conversation-centric mining takes a broader approach. It's not focused on individual items, but on the entire user interaction from the user's perspective. It's trying to understand what the user's goals were, their preferences, their emotions, their motivations, the choices they made throughout the conversation.
So it's capturing the context, the nuances of the interaction.
Precisely. And within this conversation-centric approach, they've also explored different levels of granularity. They can do this annotation at a turn level, meaning each back-and-forth exchange in the dialogue is annotated independently. This allows them to capture very specific, very nuanced attributes.
Okay, so it's like adding little notes to each line of the conversation. And I think you mentioned there's also a session level.
That's right. Session-level annotation looks at the entire dialogue as a whole, trying to extract broader contextual attributes that apply to the entire interaction.
Okay, so turn level for the fine details, session level for the big picture.
Exactly.
I'm with you so far. So when we've mined all these attributes, what happens next?
Well, that's where the annotation module comes in. This is where those mined attributes and their corresponding values are actually used to enrich the agent's memory. And they do this in a structured way, essentially creating key value pairs for each memory instance.
Okay, so it's like creating a detailed index for each memory.
Precisely. So you might have, for example, for a movie memory, you'd have title, director, genre, all those attributes neatly laid out with their specific values.
I see. So each memory is nicely organized and labeled. And I noticed the research talks about two different methods for prioritizing these attributes during the annotation process: basic augmentation and priority augmentation.
Right, so basic augmentation is pretty straightforward. You just gather all the attributes without any specific order, just a simple collection. But priority augmentation is a bit more sophisticated. It actually sorts the attribute value pairs based on how relevant they are to that particular memory.
So it's like deciding which labels are the most important.
Exactly, and that can be really helpful for the retrieval process, knowing which attributes are the most defining for a particular memory.
Yeah, that makes sense. So once the memory is augmented and prioritized, how does MemInsight actually find the information it needs when it's time to retrieve something?
Well, that's where the memory retrieval module comes in. And there are two main methods they've investigated for leveraging these augmentations. The first is attribute-based retrieval, which is pretty intuitive. When the agent needs to access its memory, it generates relevant attributes based on the current context. Then it simply searches for memories that have matching attributes in their augmentations.
So it's like a keyword search, but with semantic attributes.
Exactly. Think of it like saying, I'm looking for a science fiction movie directed by Christopher Nolan. The system would search for memories that have genre science fiction and director, Christopher Nolan, in their augmentations.
Okay, that's pretty straightforward. And what's the other method?
That's embedding-based retrieval. It's a bit more complex, but also more powerful in a way. Instead of directly matching attributes, it relies on generating embedding representations for each memory. These embeddings are essentially numerical vectors that capture the semantic meaning of the memory based on its aggregated annotations.
Okay, so it's turning those semantic attributes into numerical representations.
Right, so each memory gets its own unique meaning signature in the form of a vector. And when the agent needs to retrieve information, it also generates an embedding for the current context. Then it uses a similarity search technique to find the memories whose embedding vectors are closest to the query vector.
So it's like finding the memories that are closest in meaning to the current need.
Exactly. And they specifically mentioned using FACE for this, which is a library optimized for performing really fast similarity searches across huge data sets of these vectors.
Because when you're dealing with millions of these meaning signatures, you need a tool that can handle it, right?
Absolutely. And they actually experimented with different ways of creating these embeddings, either by averaging the individual embeddings of each attribute or by embedding all the augmentations together. Interestingly, they found that averaging the individual embeddings actually worked better.
Interesting. So each attribute get its own representation, and then they're combined. So we've got the three modules, mining those semantic attributes, annotating the memory, and then retrieving information. But what really sets MemInsight apart is the autonomous part, right?
That's the real game changer here. The fact that it doesn't rely on humans to define those attributes. The LLM agent itself figures out what's important to remember and how to structure that information within its memory.
So it's learning how to learn in a way.
Exactly. And that autonomy allows for a much more adaptable, much more context-sensitive memory system. It can evolve and change as it encounters new tasks and new information.
That's pretty incredible. So how did they actually test this out? What kind of experiments did they run to see if MemInsight really lived up to the hype?
They put it through its paces across three very different task scenarios: conversational recommendation, question answering, and event summarization.
Okay, so a good mix of tasks to really challenge it.
Exactly.
Let's start with question answering.
Sure. So for this, they used a data set called LoCoMo, and they compared MemInsight against a baseline, which was the Claude 3 Sonnet model without any augmentation. They also included a standard RAG baseline using DPR, which stands for dense passage retrieval. And with MemInsight, they built the memory from historical dialogues using conversation-centric, turn-level augmentations because the questions often required understanding specific parts of the preceding conversation.
Okay, so they set up a pretty solid benchmark to compare against.
Absolutely. And the results were really impressive. MemInsight, using both the attribute-based and embedding-based retrieval methods, outperformed both the unaugmented baseline and the RAG baseline. And not just by a little bit. We're talking about significant improvement in overall accuracy, as measured by the F1 score, and also in recall, which tells us how well it's finding the correct answer within the top retrieved memories.
So it's not just finding any answer, it's finding the right answer.
Exactly. And they saw particularly strong improvements in multi-hallop questions, which are questions that require piecing together information from different parts of the dialogue history.
That's really interesting. So it's not just remembering, it's understanding the connections between those memories.
Exactly. And they also found that priority augmentation consistently worked better than basic augmentation when using embedding-based retrieval, which shows the value of focusing on those most important attributes.
Okay, so it's not just about having more attributes, it's about having the right attributes. What about conversational recommendation?
Right. So for this task, they were simulating a conversational setting where the agent recommends movies. They used the LLM-REDIAL dataset for this. And they compared MemInsight against the baseline Claude 3 Sonnet model again, but also against the performance reported in the original LM-REDIAL paper.
Okay, so again, a good mix of benchmarks.
Yeah, and here the results were a bit more nuanced. They found that using MemInsight with comprehensive augmentation led to better performance in terms of recall and NDCG, which measures how well the recommended items are ranked. But what was particularly interesting is that attribute-based filter retrieval actually achieved similar performance to the baseline, but using a much smaller portion of the memory.
So it's more efficient.
Much more efficient, which is a big deal when you're dealing with these massive data sets.
Yeah, absolutely. And I noticed they also did some subjective evaluations using LLMs.
Oh, that's one of the coolest things about this research. They went beyond the traditional quantitative metrics and actually used other LLMs to judge the persuasiveness and relatedness of the recommendations. And what they found is that MemInsight actually made the recommendations more persuasive.
So even if the hard numbers weren't dramatically different, the recommendations just felt more convincing.
Exactly. And that's a really important aspect of human-AI interaction, that feeling of being understood and persuaded.
Absolutely. Did they look at the attributes that were being generated autonomously? Any interesting findings there?
Yeah, there were some really insightful observations. They found that genre was a very common attribute, which makes sense when you think about movie recommendations. But this analysis also highlighted the need for that priority augmentation mechanism because some attributes are clearly more important than others in driving user preferences.
So the AI is picking up on what matters to people.
Exactly.
What about the event summarization task?
So for this, they used the LoCoMo dataset again, but this time they were focusing on extracting key events from conversations. They compared MemInsight to a baseline that just used the raw dialogues, and they also tested using different levels of augmentation, turn level versus session level.
Okay, so really digging into the different ways to use MemInsight.
Right. And they found that MemInsight actually did pretty well, achieving performance comparable to the baseline, even when it was only given the parts of the dialogue that actually contained the events.
So even with limited information, it was still able to extract the key events.
Exactly, which speaks to the effectiveness of the augmentation. And they found that turn-level augmentations tended to provide more precise information about specific events. They also made an interesting discovery about the impact of the backbone LLM they were using for the augmentation. They found that using Claude 3 Sonnet for generating the augmentations actually improved the performance of Llama v3 when it was used for the summarization task.
Wow, so the AI that's doing the remembering and the tagging actually affects the overall performance of the system. That's a really important takeaway.
Absolutely. It highlights the importance of that initial stage, that understanding of the data. And speaking of the AI behind it, they also did some qualitative analysis of the augmentations generated by different LLMs. And there were some cases where they saw hallucinations, particularly with the Llama model, where it was generating information that wasn't actually present in the dialogue. But Claude 3 Sonnet seemed to be more stable and consistent.
So it's not perfect yet. There's still room for improvement in terms of the reliability of those augmentations.
Right. And the researchers are very upfront about that. They acknowledge that the effectiveness of MemInsight depends heavily on the quality of those LLM-generated annotations. And they also point out that current evaluation metrics might not fully capture everything that's important in these complex AI systems.
So we're still learning how to measure what it means for an AI to have good memory.
Absolutely. It's a rapidly evolving field, and there's a lot of exciting work ahead.
So to wrap things up, what's the big takeaway for our listeners? What's the core innovation of MemInsight?
I think the key innovation is the autonomous approach to enriching the memory of LLM agents with semantic understanding. It's not about predefined rules or human annotations. It's about empowering the agent itself to learn and structure its own memories. And that's a huge step towards creating truly intelligent AI systems.
And what are the main benefits, the things people should remember from our deep dive?
Well, we've seen that this autonomous augmentation leads to more efficient information retrieval. The agent can access the information it needs faster. It improves contextual awareness so the responses are more relevant, more coherent. And overall, it just improves performance across a range of tasks, especially those subjective evaluations, where it's about making recommendations that are persuasive and that feel personalized. It's about making the AI not just a repository of data, but a system that can truly learn from and use its experiences.
And I think that's the real takeaway. MemInsight is about making LLMs not just bigger, but truly smarter in the way they handle information. What about potential applications? Where could we see something like this making a real difference?
I think the potential applications are vast, enhancing any kind of autonomous agent, virtual assistants, robots, anything that needs to learn and adapt in real time. And of course, conversational AI systems, making those interactions more engaging, more personalized, more human-like. And then there's the whole field of information retrieval, making it more efficient, more context-aware. And the researchers even talked about combining MemInsight with existing RAG models, which could lead to even more powerful systems.
It's really fascinating stuff. So as we wrap up, I want to leave our listeners with a final thought. With LLMs becoming more and more integrated into our lives, how might autonomous memory augmentation techniques like MemInsight change the way these agents learn, adapt, and interact with us in the future? What does it mean for the future of AI, for how these systems manage knowledge and evolve over time? It's a really exciting and potentially challenging future to think about.